We are here again. Welcome to Chem Classroom with Auntie Taiwo. If you have not subscribed, kindly do so and tell your friends, share, like and view, and even put a comment in the comment section and see how you are keeping up with the lessons. So today we'll be discussing some of the foundation topics in chemistry. I discovered that a lot of students actually do not understand this concept, and that is why I said, okay, today let us do this so that we can have a better understanding. So today we'll be going to concept of valency and oxidation number. You see, valency and oxidation number is very, very important even in the formation of our compounds. Yes, at times we see some compounds, we start to wonder, how are these things formed? Yes, so now valency is the combining power of an element. Yes, then at times we can also say the valency of an element is being determined by the number of electrons at the outermost shell. For instance, using the key element shell, sodium is 11. So if I'm to break it into shell, I will do 2, 8, 1. Okay, so now I will tell you that the valency of what? Of sodium is what? 1. Okay, now, and sodium is also in group 1 because the valence electrons determine the group in which an element belongs to. Now going to oxidation number. Now the oxidation number is the charge on your atom, and this charge can either be positive or negative. Now I usually break this down to my students. I say oxidation number is the number of electrons that an atom is willing to give out or to receive. Yes, that way we try to understand it better. Now, and this oxidation number can either be positive or negative. Now, the positive one is the one giving out the electrons, while the negative one is the one receiving. Now, let us still consider sodium. Sodium has just 1 electron in the outermost shell. So sodium will be willing to give out this 1 electron to any atom that wants to collect 1 electron as well. So that is why we will now have sodium to be what? Positive. So the charge on sodium is what? +1. Now sodium will look for another atom that needs that 1 electron to fill up the octet structure. Now a very good example here is also what? Chlorine. Okay, so chlorine is 17. So we have 2, 8, 7. And if you look at what we have on the board, chlorine needs how many electrons to complete the octet structure? Chlorine needs just 1 electron to complete the octet structure. So now, the valency of chlorine is what? 7. But the oxidation number of chlorine is going to be what? -1. Because it needs just 1 electron to complete the what? Octet structure. So by the time chlorine collects 1 from sodium, chlorine will be -1. So the oxidation number of chlorine is what? -1. Okay, now, so that is how our sodium chloride is being formed. Now let us move and talk about what we call radicals. Now radicals are group of what? Charged atom. They are a group of atoms, then they have a charge on top. And that charge, like I tell students, the charge, you are relating that charge to every component of that atom. You are not just using that charge for only one element. It's together. So you have something like this, CO3 2 minus, NO3 minus, NH4, that this is the ammonium ion, okay, SO4 2 minus. These are what we call radicals. Now, these radicals, look at our CO3 2 minus. Now, everything here has oxidation number of what? -2. So now, as it is now, it's going to look for an atom that is willing to give 2 electrons. Now, a very good example is our group 2 elements, your calcium or magnesium. Now, calcium is what? 20, 2, 8, 8, 2. So calcium will be willing to give out these 2. Also, magnesium will be willing to give out these 2, 2, 8, 2. Okay, so it will be willing to give out these 2 electrons. So, and when that happens, your calcium 2 plus, and with this, they will cross out each other. So that is how our calcium carbonate is being formed. Yes. Then another one, you can have some elements that do not really, here we have 2 positive from the carbon, 2 electrons from the carbon, and calcium willing to give the carbonate, yes. But in a situation whereby you have them not to be balanced, okay, we'll be using, okay, let us use sodium and NO3 to NO3 minus. Sodium is what? Sodium has just 1 electron to give out. Okay, they will still balance Na. Okay, let us use SO4 2 minus. Let me use sodium and SO4 2 minus. Yes, sodium is willing to give out only 1 electron, and SO4 2 minus is willing to collect 2 electrons. So what we are going to do here is to what? Produce 2 atoms of the sodium. And these 2 atoms of the sodium will give what? 2 electrons. So with this, is going to form a bond with the SO4. So these 2 will cross out with this. So we'll now have what? Na2SO4. Okay, so that is how bonding takes place in chemistry. There must be an element, an atom willing to give, and there must be another atom willing to receive. And at times too, they form what we call the covalent bonding. Yes, they share electrons. So this is how the concept of valency and the concept of oxidation number come to play. So you can form other compounds using the what? The other radicals. Okay, let me just form one with our ammonium ion. Okay, we also have OH minus. So our ammonium ion is +1, OH minus 2 is -1. So it will form ammonium hydroxide. So that is how our ammonium hydroxide will be formed. Okay, so please practice some other compounds with the radicals. Get a positive, the cations that will blend with the negative one, and form your own compounds and put in the comment section. All right, so please keep up with the lessons. Thank you for staying tuned to the class. All right, see you some other time. Thank you.